So now let's look at some examples of applying these perpendicular bisector theorems. So for each of these, we're going to find the measure that it's told for us to find. And so see, we first want to find mn in this first problem. And so I see, looking at my diagram here, that this line P is the perpendicular bisector of ML. Again, I know that because one, it's intersecting at a right angle, so that means it's perpendicular. And then two, I see that it's exactly in the middle that's bisecting this segment ML. And I know that from these congruent markings. And so since we have the perpendicular bisector, from our perpendicular bisector theorem, we know that the point that lies on that perpendicular bisector is equal distance from the endpoints. So that means this point N is equal distant from L as it is to M. In other words, NL is congruent to MN. So MN is equal to NL. Well, we know the length of NL is 2.6, so that means that MN is also equal to 2.6. Okay, so for number 2, we want to find BC. So here I see that I have two congruent segments here. They're both length 38. So I know that AB is equal to AC. And I see that AD is perpendicular to BC. And I know that from this right angle that's here. And so because of that, we know from the converse of the perpendicular bisector theorem that the point that lies on the perpendicular bisector lies on the perpendicular bisector of the segment. And so since I have that AB is equal to AC, that means that this line is the perpendicular bisector. So that means that DC is also equal to BD. Now, this problem is wanting me to find BC. It's wanting me to find this entire length. Well, since these are both equal to each other, that means that BC is just going to equal to twice the length of DC, which is the length given to us, that's 12. So it's going to equal to 2 times 12, and so BC is equal to 24. Another way you could have thought about that is that since these are both congruent, that means that BD is equal to 12, and by our segment addition postulate, you could have just done 12 plus 12 to get that entire length, which is 24. Okay, number 3, I see I want to find the length of TU. Here, this one's just like number 1. I see that I have the perpendicular bisector. Again, it's intersecting TV at a right angle, so I know it's perpendicular. And it's intersecting right at the middle, so I know it's also a bisector. And so we know from the perpendicular bisector theorem that that means that TU is equal to UV. So I have 3x plus 9 is equal to 7x minus 17. And I want to solve that. So I'll subtract 3x from both sides. Add 17. No, not 46, 4x. And then divide both sides by 4, and you get that x is equal to 6.5. Now the question's asked me to find the length of TU, so that means I need to plug x back in. And so TU is equal to 3x plus 9. Well, instead of x, I'm just going to replace that with 6.5. 3 times 6.5, I get 19.5. And then when I add 9, I get that TU is equal to 28.5. Okay, one more example for this video. Here we're going to use a diagram and the given information to find the indicated measure. So for part A, it says that ZX is the perpendicular bisector. And so it's the perpendicular bisector. That means that WX is congruent to XY because it's bisecting. We know that YZ is equal to 13.75. And we want to find WZ. So we want to find the length of this one. Well, again, we know from that perpendicular bisector theorem that these two are going to be congruent because Z is the equidistant from W as it is from Y. So that means that WZ is equal to 13.75. Okay, now let's look at this next one. Now it says find WX when WZ is equal to 20.5. WY is equal to 14.8. And YZ is also equal to 20.5. So noticing from this information I'm given, I see that these two side lengths are congruent to each other. And so I know from the converse of my perpendicular bisector theorem, that ZX actually is the perpendicular bisector of WY. And so that means that WX is congruent to XY. So we're going to find the length of WX. And I know that the whole length here is 14.8. And I also know that WY is equal to twice the length of WX. Well, WY is just equal to 14.8. And so dividing both sides by 2, I get that WX is equal to 7.4. Okay, now for this last one, it tells me that ZX is the perpendicular bisector of WY. So we again have that WX is congruent to XY since this is the perpendicular bisector. And it tells us that WZ is equal to 4n minus 13. And YZ is equal to n plus 17. I want to find the length of YZ. Well, from our perpendicular bisector theorem, I know that WZ is congruent to YZ. So I have YZ is equal to, or WZ is equal to YZ. And so I need to solve 4n minus 13 is equal to n plus 17. So I'm going to first subtract n from both sides. And I get 3n minus 13 is equal to 17. Then I'll add 13. And I get 3n is equal to 30. And then divide both sides by 3, and I get that n is equal to 10. However, I'm not done. It's wanting me to find the length of YZ. So I need to plug that back in. YZ was n plus 17, so I need to replace that n with 10 plus 17. And I get that YZ is equal to 17.